It's maybe the biggest question there is, right? The one that gets at the heart of, well, everything. Where did all this come from? Not just the planet, not just the stars, but space itself, time itself, you and me. How did it all begin? Well, today we're diving deep into the incredible physics of our cosmic origins. This is the question that drives so much of science, of philosophy, of just plain human curiosity. It's the ultimate starting point. How in the world did our universe actually begin? And for most of us, if you stop and think about it, the answer that pops into your head feels simple, kind of obvious even. Before there was something, there must have been, well, nothing. Just a huge, empty, silent void. A blank canvas before the painting. Seems to make sense, doesn't it? But here's the twist. This is where it gets really, really cool. What if our entire idea of nothing is just completely wrong? What if the void was never actually empty to begin with? This one idea, it changes absolutely everything about how we understand the beginning. So let's start right there by taking on this idea of a perfect empty void. Because modern physics tells us something pretty startling. True, absolute nothingness probably can't exist. The fundamental laws of the universe just don't seem to allow for it. So here's the key takeaway. The universe didn't just appear out of a passive, dead, empty space. Instead, the science suggests it emerged from a pre-existing state that was buzzing with activity and packed with potential, all happening on the tiniest possible scale, the quantum level. Okay, so what in the world was this active quantum state? The best way to think about it is like a hidden engine for the universe, or maybe like a quantum fizz, something that was bubbling away before space and time as we know them even existed. And this brings us to a concept called the quantum vacuum. Now, the name is a little misleading because it sounds empty, but it is anything but. It's the lowest possible energy state of reality, yeah, but it's more like a simmering sea of energy that's constantly fluctuating. It is never, ever truly still. This is the baseline of existence. So how can something be bubbling with energy if it's supposed to be the lowest energy state? Well, it's all thanks to one of the most famous rules in all of physics, Heisenberg's Uncertainty Principle. To put it simply, the principle creates a kind of cosmic loophole. It allows for tiny bits of energy to be borrowed from the vacuum just for a moment. And what happens when that energy is borrowed? A pair of what we call virtual particles, one of matter, one of antimatter, just pops into existence out of nowhere. They exist for a fraction of a second, and then they find each other, annihilate, and poof, their energy goes right back into the vacuum. And the craziest part? This is happening constantly, everywhere, even in the empty space in the room around you right now. So, if the quantum vacuum is always fizzing like this, why don't new universes pop into existence all the time? What made our beginning so special? Well, it seems it took one very particular, very powerful fluctuation to get the whole show started. The leading theory here is called cosmic inflation, and it says that one of these quantum fluctuations was different. It was unbelievably intense, so powerful that it didn't just vanish back into the vacuum. Instead, it triggered a kind of runaway chain reaction, a hyperfast expansion not into space, but an expansion of space itself. And we really have to get this part right, because it's the biggest misconception out there. The Big Bang was not like a bomb going off in a big empty room. There was no room. It was the fabric of reality itself that was stretching and expanding, everywhere, all at once. The entire universe we see today was packed into that initial expanding point. This, of course, leads us to the next totally logical question. It's the one everyone asks. If the Big Bang was the beginning, what was happening before that? And I've got to tell you, the answer to this is one of the most mind-bending ideas in science. The question itself is broken. Asking what came before the Big Bang is like asking what's north of the North Pole. There's no such thing. The very concept of before, the flow of time itself, it didn't exist yet. Time is woven together with space. It only began to tick forward as space began to expand. All right, so we've got this incredible moment of expansion. We have a universe that's born, and it's filled with pure, incredibly hot, dense energy. So how do we get from that to planets and stars and galaxies? It all goes back to a rule you probably remember from science class, the law of conservation of energy. The total amount of energy in the universe is fixed. You can't make it, you can't destroy it, you can only change what form it's in. And the early universe, well, it was the greatest transformation of all time. So as this new universe expanded, it started to cool down. And as it cooled, that raw, frantic energy began to condense, kind of like steam turning into water. First, it clumped into tiny particles like quarks. Then, as it got even cooler, those quarks stuck together to make protons and neutrons. And eventually, things were cool enough for whole atoms to form. From there, good old gravity took over, pulling all that new matter together to build the stars and galaxies we see today. Now, we have to be honest here. Everything we've just covered is our best scientific model, but we are right at the absolute edge of what humanity knows, and there are other incredible, mind-bending possibilities that scientists are exploring. So let's ask that impossible question one more time, but with our new understanding. What was going on before that one special quantum fluctuation set everything in motion? Well, some theories suggest our universe might be part of an endless cycle, a big bounce where a previous universe collapsed on itself and was reborn in our Big Bang. Other theories imagine our universe is just one bubble in a vast cosmic foam, a multiverse full of other universes. Or maybe, just maybe, the energy that makes up everything has simply always existed, in some eternal, latent form. When you put all this together, it leads to a really profound new way of looking at reality itself. It makes you realize that the world we see isn't quite as solid or fundamental as it feels. There's a fantastic way to put this. The very things we experience as a bedrock of reality, the 3 dimensions of space, the forward march of time, they might not be the base layer. They could be what we call emergent properties, things that arise from a much deeper, weirder, and more fundamental quantum reality. So, if there's one thing to take away from all this, it's this. Everything you see, everything you are made of, the space you move through, and the time you experience, it's all just different expressions of the same fundamental cosmic energy, transforming from one state to another. And that leaves us with one final, pretty wild thought to chew on. If energy can't be created or destroyed, only changed, did our universe really have a true beginning at all? Or has it, in some form or another, just always been here? Now that's something to think about.